Hello everyone, my name is James Pruitt and this is my 9th video on generating functions. Last time we were we had that Fibonacci recurrence relation, and we transformed that to an algebraic equation, and we solved for the sequence A. So we got the sequence A is equal to x over 1 minus x squared. And we said that if you have something in the denominator, or write it as a quotient like this, the denominator has to have a non-zero constant term, or this is not allowed. So you have to be careful with that, in which we have a non-zero constant term. So now I want to go ahead and figure out what this sequence is. And so we need to factor the denominator. So we're going to just use the quadratic equation, which is ax squared plus bx plus c is equal to a times x minus negative b plus the square root of b squared minus 4ac over 2a times x minus negative b minus the square root of b squared minus 4ac over 2a. So there's the quadratic equation. So now we just plug in our denominator that we're trying to factor. So we're going to negative x squared minus x plus 1 is equal to, we got a negative a there, x minus, we got a negative 1 here, which is negative and negative is 1, plus the square root of, now we got negative 1 squared is 1, and we got a negative a here and a 1, so we got negative 4 times negative 1 times 1, that's going to give us a positive 4, and a positive 1 is going to be 5. Over here, this negative 1 is going to give us negative 2. Same thing here, x minus negative 1 negative is positive minus the square root, and this is the same as this, so that's just going to be 5, and over negative 2. Okay, and what we're doing is we're trying to we're going to factor that and do a partial fraction expansion and try to create, like we did on that last example, create some form that we've already derived for, that so we don't have to work. So we don't have to work for the multiplicative inverse. So that's really what we're trying to find, the multiplicative inverse of this guy, and then we can multiply it out. So multiply x times the multiplicative inverse of this guy gives our sequence. So we got our roots, and actually I'm going to make this plus and this plus and this plus and this plus. And this is a famous number. It's called the golden ratio, and the golden ratio has a name. They call it phi, and that's equal to 1 plus the square root of 5 over 2. And it's an irrational number because the square root of 5 is an irrational number. Plus 1, let me give an, and it's approximately equal to 1.618, somewhere around there. So instead of carrying out all these square roots in this notation, it's going to get complicated if I do that. I'm going to simplify and write this as that. And the thing about this golden ratio, it's has a lot of symmetries to it. So you'll see all these funky expressions, and they simplify down. So you got to play with this a lot. If you see something that looks complicated, you could probably play with it a little, and you can get something simple. So like right here, we're going to write that as 1 minus phi is equal to 1 minus 1 plus the square root of 5 over 2. And so we'll put 2 over 2, so it's 2 minus 1. That's equal to 2 minus 1 is 1, and then we bring the negative, it's going to be a negative, we're going to bring that negative in there, so that's going to be 1 minus the square root of 5, and all that's over 2, and so that's what we got. That's 1 minus phi. So we can rewrite our roots here. We got, I'm going to change that real quick. Let's get that. Okay. I'm going to change it back. So 1 minus x squared is equal to negative x plus phi times x plus 1 minus phi. Okay, now back to our problem. Okay, so we've got our factor. So we got a is equal to, I'm going to bring that negative x up. So that's, I'm going to bring that negative sign up. So it's going to be negative x over x plus phi times x plus 1 minus phi. Okay. Now we're going to do our partial fraction expansion, and we're going to I do this is called the Heaviside cover-up method. So I'm going to, in order to do partial fraction expansion, we use the and I hope I can spell his name, Heaviside cover-up method. And so we're going to write this as a over x plus phi plus b over x plus 1 minus phi, and that's going to equal to negative x over x plus phi x plus 1 minus phi. Okay, so the Heaviside cover-up method. So what I do is I multiply defined a. I multiply by x plus phi on both sides. So that cancels that out. So a is by itself. You got an x plus phi here and an x plus phi here, but those cancel out. And then I substitute for x. I let x equal to negative phi, and so this becomes 0. And then I substitute negative x for negative phi in here, and that gives our answer. Okay, so that's negative phi over this is canceled out, that's gone, so it's negative phi minus phi, so it's 1 minus 2 phi, and this is a plus and a plus, 1 minus 2 phi. And then again, with the symmetries with phi, we can look and see what this looks like. So this is 1 minus 2 times 1 plus the square root of 5 over 2. The 2's cancel. And that's going to be 1 minus 1 minus 5, so that's just going to equal to minus the square root of 5. So that's equal to minus phi over the square root of 5. Okay. Let's see if I can squeeze b in here. And b's done the same way. I multiply by x plus 1 minus phi on both sides. This is going to cancel out, and it's going to cancel out over here, and it's going to be left right here in the numerator. And so when I want to substitute for x, phi minus 1, or negative 1 minus phi, which is phi minus 1, and so that becomes 0. So that's left with a negative phi minus 1 over, and then I plug in, this is gone, phi minus 1 plus phi is 2 phi minus 1, 2 phi minus 1, and that's equal to 1 minus phi over, and again I want to see if there's some simple form for this 2 phi minus 1. So that's 2 times 1 plus the square root of 5 over 2 minus 1. Okay, minus 1. So the 2's cancel out. So 1 minus 1, so that's just equal to the square root of 5. So you got 1 minus phi over the square root of 5. And we're going to come on down here. So we got a, which is negative phi over the square root of 5 times x plus phi. Let me make sure I got that. And that's going to be plus, and then I come back up here, what do I got here? 1 minus phi, 1 minus phi over the square root of 5 times x plus 1 minus phi. And what do we say? That's our equal to our a. So now we're almost there. Let's see what we're sitting on time. We're almost there. So what we're doing this, why we're doing this, is we're trying to build up a database of sequences that we know their multiplicative inverses for. So we know that certain sequences the multiplicative inverse, and we try to simplify and manipulate it until we get it into the sum of some or product of some sequences that we already know we know the sequences, we know what they are. So the one that we know what is, the multiplicative inverse of 1 minus cx, we know what that is. 1 over c minus x is equal to 1 plus cx plus c squared x squared plus dot dot dot. We've already shown that. So we want to get this guy right here in this form. And so what I'm going to have to do is distribute out this phi. So you're going to get negative phi over the square root of 5 times phi. Now I pulled that, so that's 1 over phi, x over phi, and that's plus 1. So, but I want to, okay, I'll just go ahead and write that down. X over phi plus 1. And the phi's are gone. And that's plus 1 minus phi over the square root of 5 times 1 minus phi times x over 1 minus phi plus 1. And then we're going to, let's keep on going down here, simplifying. So that's equal to, and I'm going to move the negative one over here, so, and bring this one over here. So, and this cancels out. Now we got 1 over x over 1 minus phi plus 1 minus, and then we have, okay, I'm going to keep going. I'm goofing up here. 1 over x over 1 minus, oh me, what time is it? And this, I don't have time for this stuff. Let's see. My head's starting to, okay, let's get this done right. I'm going to watch the time so I don't run out of time. I'm going to move this over here and move this over here, so I get a positive 1 over here. So what? And I'm going to pull out the 1 over the square root of 5. So 1 over the square root of 5 is equal to 1 over, and this is x over 1 minus phi plus 1 minus 1 over x over phi plus 1. Okay, and then I'm going to, let me pull this down real quick. Okay, so now that's going to equal to 1 over the square root of 5 times 1 over, and I'm going to multiply by a negative. I'm going to switch that around so it looks like our, I want that to look like this term right here, so I can apply that knowledge. So that's going to equal to 1 minus 1 over, that's going to be a minus 1 minus phi times x minus 1 over 1 minus 1 negative 1 over phi times x. And I'm going to stop right there, and we'll finish up next time. Okay, thanks. Talk to you in a little bit.